So here, this is the unit circle. The unit circle is basically, well, first of all, you've probably seen the unit circle before. If you're familiar with this is probably some basic stuff. So if you're familiar with the unit circle trig ratios, then you can just skip the trig algebra, the trig algebra part of this video. But if you're not, then let me explain what the unit circle is to you. So the unit circle is basically a circle that measures like the measure of the angle in terms of degrees, radians, and when we get to it, coordinates. So one thing I do want to point out first is that to convert from degrees, say you have like 45 degrees, which is just 45 over 1, right? To convert that to radians, you have to multiply it by pi over 180. And when you put in the math, you get pi over 4. That's how you convert it. Likewise, if you want to convert pi 4 to degrees, you'll multiply it by 180 over pi. And you get 45 degrees. As you head towards calculus, you will be prioritizing radians over degrees. So we're only going to talk about degrees briefly. But basically what this is saying is that 30 degrees is equal to pi over 6. 45 degrees is equal to pi over 4. Whoops, didn't mean to do that. Pi over 3 is equal to 60. It just keeps going on and on. Pi in a unit circle is just a 180 degrees. 2 pi is just 360 degrees. You kind of just have to memorize this, honestly. So the most basic trig ratios we have right now are sine and cosine. So when we have sine theta, we're basically referring to the y-coordinate. Cosine theta, we are referring to the x-coordinate. Simple enough. Tangent theta is basically just y over x. Or in other words, that's sine theta over cosine theta. And if you don't get that, it's because y equals sine theta, cosine equals x. So you can just put them in like this. So tangent theta is equal to y over x, or sine theta over cosine theta. Then you have the more, the less familiar trig ratios. You have cosecant, which is equal to 1 over sine theta, or just 1 over y. Well, actually, it's equal to r over y. It's just assuming that the radius is already 1, as it is in the unit circle. In the unit circle, the radius is always 1. Then we have secant theta, which is equal to 1 over cosine theta, 1 over x, or r over x. Oh, and also, in cases when r is not equal to 1, this would be your formula for a cosine. And same thing for sine. Oops, I meant to say r. I'm messing this up. But yeah, you get the idea. And then we have cotangent, which is equal to 1 over tangent theta, also equal to cosine theta over sine theta, and also equal to x over y. So those are the 6 trig ratios. Now let's see how we can apply that to the unit circle. So in case you've already forgotten, this represents pi over 3, which is 60 degrees. Pi over 4, which equals 45 degrees. And pi over 6, which equals 30 degrees. I'm just telling you the degrees, telling you the degrees because just so if you're not familiar enough with the unit circle, but we're going to ignore degrees for now because we need to steer towards radians now. All right. So we've already been told that sine theta equals y and cosine theta equals x. So basically what that's saying is that the cosine of, say like we have a triangle and we know its hypotenuse, like say it's 1, right? When we're finding the cosine of, say, its angle, like 30 degrees, the cosine of its angle would be this. Oh, no, not that. Whoops. The cosine would be this. Would be the x value. Similarly, the sine value would be this. The opposite. Sine theta would equal the opposite. Cosine theta would equal the adjacent. So let's try to find the cosine and sine of pi over 6. So we have pi over 6 here. Well, when you find the cosine of pi over 6, if you put this into your calculator, you're going to get the square root of 3 over 2. When you put in sine theta, sine pi over 6, you get 1/2. So you can go ahead and put this as your coordinate. There you go. Now let's try to find the what was I gonna say? The cosine of pi over 4. So for pi over 4, cosine of pi over 4 is gonna equal square root of 2 over 2. Sine pi over 4 is also gonna equal square root of 2 over 2 because, you know, these two sides are equal, and it is this side that's different. So for that, you can say for your coordinate, negative 2 over 2, negative 2, square root of 2 over 2. I don't know why I'm mispronouncing so many things today. And square root of 2, root 2 over 2. Then for pi over 3, cosine, which is the x value, would equal 1/2. Basically a reverse of pi over 6. Yeah. So that would be your coordinates. And one more thing, your coordinate for here, which is 0, your coordinate here would be 1, 0. Because x equals 1, this is the x point here would be 1, and we're on the y-axis here, so it's just 0. The coordinate here, which is pi over 2, or otherwise 90 degrees, if you've forgotten, the coordinate here would be 0 for the x coordinate and 1 for the y coordinate. So yeah, that's how you find the coordinates. And these coordinates that we've just solved for for the most part, they're gonna stay the same throughout the next three quadrants. The only thing that's gonna change is our their positive and negative signs. So what I'm talking about there, say we have quadrant 2, right? The y value in quadrant 2 is still positive. So we're still going to have positive 1/2, positive root 2 over 2, and positive root 3 over 2, right? But our x values are going to be negative, which means the cosine theta here is going to be a negative value. But it's going to be the same for all of these. So for, say, this angle right here, which is 4 pi over 3, our x-coordinate here would be negative 1/2. And then our y-coordinate would still be root 3 over 2. Likewise, say we're going into quadrant 3, in which they're both negative. So, for instance, say we want to find 7 pi over 6, which is this angle. Our x-coordinate would be negative root 3 over 2. Y would be negative 1/2. And you kind of get the idea. Quadrant 4, cosine is positive, sine is negative. Same values. The only thing that changes are its positive and negative signs. You can look that up for yourself. One thing I will finish off on, though, for the unit circle. Pi over 3 is going to correspond with these angles. This is not really drawn well, so don't worry. Pi over 4, or pi's over 4, going to correspond with that. Pi's over 6, going to correspond with that. So suppose you want to find the value of sine of pi over 6 minus cosine pi over 4, right? And you want to find the value of that. You're basically subtracting it. So we went over the unit circle briefly. If you're not really familiar with this problem, it's probably because we didn't go over it too well, but I'll walk you through this. So we went over that the sine of pi over 6 is equal to what? What's the y value equal to when theta is pi over 6? You should know what pi over 6 equals in degrees by now. But if you don't, it's 30 degrees. And the sine or y value, y coordinate of that would be 1/2, right? For cosine pi over 4, root 2 over 2. They both have the same denominator, so you just have to substitute them. You're basically just saying 1/2 minus root 2 over 2. This is basically what you're saying. The key here is substitution. You end up with this. You can't really simplify this, so this is pretty much your final answer right here. Seems simple enough. Let's go over something a little less familiar. Say you have secant pi over 6 times cotangent of pi over 4. Now, we didn't really go over this in the unit circle, but we did go over the ratios. We do know that secant theta is equal to 1 over cosine theta. And the cosine of pi over 6 is equal to what? Root 3 over 2. So all you have to do there is find the secant of it, which is just 1 divided by root 3 over 2, or what you could do, keep change flip, This is what secant pi over 6 equals. So we could just put that over here. And then for cotangent, if we erase all of this, we would have, cotangent is equal to 1 over tangent theta. And you could also think of that as cosine theta over sine theta. Let's just think of it as cosine theta over sine theta for now, just to keep it simple. Cosine of pi over 4 is equal to sine of pi over 4, which is root 2 over 2. Cancel, 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 cancel. That's just 1. So you're pretty much just multiplying it by 1. And anything times 1 is just itself. So your answer here, pretty simple. The key here is just substitution. Really. That's all you have to do. You have to substitute. Make sure you know the unit circle by heart here. And then it's actually not that complicated. So say we know that theta is equal to 3 pi over 4. Now we want to find all 6 trig ratios. We're talking cosine, sine, tangent, cosecant, secant, and cotangent. So let's find the easiest first, cosine and sine. So cosine, let's color code this a little bit actually. Cosine of 3 pi over 4, which is just 135 degrees, is equal to negative root 2 over 2. The reason it's negative is because we're in the second quadrant now, and the x coordinates in the second quadrant are negative. So that means cosine would be negative here. Sine of 3 pi over 4, just root 2 over 2. To find the tangent, it would just be negative 1. The reason it's negative 1 is because if you recall the way we found cotangent last time for pi over 4, you would remember that we would just do keep change flip, multiply root 2 over 2 by 2 over root 2. The denominators and numerators cancel out and you just get 1. Here's the same thing, except we have a negative sign, and that's why we get negative 1, because that negative sign stays in play. Now let's do secant 3 pi over 4. All you have to do here, because we know secant is equal to 1 over cosine. Oh, and also this is negative, because cosine is negative. I actually forgot that. Then you have cosecant, which is pretty much the same thing, except no negative sign, because sine is not negative. You have cotangent, which is just negative 1. Kind of the same as tangent, because these two values are equal to one another, and it's kind of the same thing if you just do the math. But yeah. Oh, you can actually simplify this. I knew I was forgetting something. You can kind of simplify these. You don't really have to, but this is another way to do it, because the 2's cancel. So you're left with negative root 2 and just positive root 2. That's it. Once again, cosine 9 pi over 4, just root 2 over 2. Tangent of negative 6 pi, well, take it this way. 2 pi equals 360 degrees, right? And in that case, x is 1 and y is 0. So the tangent of that would just be 0. And 4 pi, we're also equal to 360 degrees because it's all periodic. So 6 pi is also going to be 360 degrees. Regardless of whether or not it's negative, we still have 60 here, 0 here. This is just 0. You're adding these two together, you should get root 2 over 2. Now let's try something a bit difficult. Let's take the big leap now. Say you have secant squared 18 minus tangent squared 18. It's all fun and games until we see squared in the trigs. But let me tell you where this comes from. So you may recall the Pythagorean theorem, which says that x squared plus y squared equals r squared, or just 1. So that's kind of where we get our thing here. Because when x squared is x squared, or when x is x squared, then we have cosine squared. Because cosine corresponds to x. And same thing for y. Sine squared. Remember this formula. Take a picture of it if you have to. And then for tangent squared is equal to sine squared over cosine squared. And to find secant, I'm just giving out random formulas now. Tangent squared plus 1 equals secant squared. You kind of see where this is going a little bit. Likewise, cotangent squared is equal to cosine squared over sine squared. And cosecant squared is equal to cotangent squared plus 1. You just need to memorize these formulas. And then the key for this is to derive. Not derivatives in calculus, but just very simple pre-calculus type derivations. So when we're looking at secant of 18, we know that the secant of 18 is equal to tangent squared 18 plus 1. And then tangent squared of 18 is pretty much just equal to sine squared of 18 cosine squared of 18. How do we get this? We got this from the formulas that we just went over. And then to simplify this more, tangent squared 18 is equal to this entire thing. So you can just erase all of this real quick. Now realize that these two have the same denominators. And we just have this really awkward 1. Doesn't really fit into the party, huh? So what we have to do, we have to infer that 1 equals cosine squared of 18 over cosine squared of 18. When you do that, you have this entire thing. Now we can perform subtraction because we have the same denominators. So let's do this. You can distribute the negative to sine squared 18. You realize that sine squared 18 minus sine squared 18 is just 0. These two cancel out. These two combine. You're going to end up with cosine squared of 18 over cosine squared of 18, which if you refer back to here, is just equal to 1. So 1 is your final answer. This is what this entire equation equals. Let's go over another one. What does this equal? If you want, you can pause this video and try it for yourself, but I'm going to do this right here. So remember that cotangent is equal to 1 over tangent. Tangent of 10 can also be expressed by tangent of 10 over 1, because it's just tangent of 10. If you divide tangent of 10 over 1, you still get tangent of 10. So they're essentially just equal. On the other hand, though, this is what we get, what we're multiplying by essentially, because this represents cotangent of 10 because of what we just talked about, right? Or based on what we just talked about. But you're going to find out these two cancel and these two cancel, leaving another basic 1. So the key here, the main key here, when it comes to trigonometric algebra, which is not actually what it's called, I just like to call it that. The key to trigonometric algebra is to really know what everything is. Like, know what cotangent represents, what tangent represents, what everything represents. And you have to derive it. This really, in my opinion, this prepares you for AP Calc really well. So let's say secant of theta equals 3. So what's the value of sine squared theta? So what you're going to realize here is you're going to realize that secant of theta, or you can solve this for yourself if you want, but this is kind of a tricky question because we do know that secant of theta is equal to 1 over cosine theta, which is equal to 3. One thing leads to another, and you will find out that when you have this together, you can multiply cosine theta on both sides, divide 3 on both sides to derive cosine theta, because you will need to know what cosine theta is in order to solve for sine squared theta in this problem. Then you relate back to the Pythagorean theorem, because we're looking for sine squared, right? We know that this equals 1. And the way to find sine squared now you might be wondering, but we don't know what cosine squared is. Actually, we can figure that out. Because cosine squared is just x squared. Cosine by itself is just x. So all we have to do here is square it. We already know what cosine represents. So if we just square this, whoops, not 3. We find out that 1/9 is equal to cosine squared. All we have to do now, plug it in. And there you have it. Sine squared theta is equal to 8/9.